Assalamualaikum warahmatullahi wabarakatuh. We are going to continue our discussion on nucleophilic substitution mechanism. For today, we focus on SN2. The number 2 means bimolecular. Okay, why bimolecular? In this mechanism, we have only one step, and in the only step, we have two molecules in the starting material. Okay, we have nucleophile and also the haloalkane. Okay, in this mechanism, what happened actually? The nucleophile attack the carbon from the backside. Okay, we call this as backside attack. The position of nucleophile must be opposite side with the X, which is the halogen in the haloalkane. Okay, because in this reaction, we want to break the bond. Okay, the rate is slow. Okay, when you want to break a bond, the rate must be slow. Okay, in this step, after the nucleophile attack the carbon from backside, okay, the carbon and halogen and also the nucleophile will form a temporary bond, okay, which is represented by the dotted line here in the structure. Okay, and this structure is called transition state. Okay, so in the transition state, we can see that there is a negative sign outside the box. Okay, why we have negative sign? Okay, it shows that the carbon has extra electrons or extra bonds. As we know, before this we have learned that carbon must have only 4 bonds, not more, not less. Okay, but now we can see that there are 1, 2, 3, 4, 5 bonds of carbons. So it means carbon here has extra electrons. So we put the sign negative to show the extra electrons at the transition state structure. Okay, so X here is the good leaving group. Okay, what does it mean by leaving group? Okay, X is a good leaving group which is easy to leave a compound, okay, so that compound can form a new bond with another nucleophile. Okay, so we continue. Okay, in the first step also, after the transition state is formed, the X will leave the group. Okay, so because C can have only four bonds, now it has 5 in the transition state, so it is not good for carbon, so X will leave the compound. So after the X leave the compound, okay, the new product will be formed. Okay, so the new product here depends on what type of nucleophile used in the reaction. Okay, and because we want to break the bond between C and X, the rate of reaction is fast. Okay, so the byproduct will be the anion, which is X minus. Okay, so in SN2 reaction, the nucleophile attacks from the backside, okay, of the electrophilic carbon. That is from the side directly opposite bonded to the halogen, which is the X. Okay, so backside attack causes the product form has inverse configuration. Okay, inverse configuration from the original configuration. So this one is the original configuration. Okay, but this one, in the product, we can see the structure has been inverse. Okay, inverse configuration. So it is a different side of the configuration. So the reaction backside attack, okay, turns the tetrahedron of carbon atom inside out like umbrella caught by the wind. Have you seen umbrella caught by the wind before? Maybe some of you, yes. Okay, this is what happened in the reaction. Nucleophile will attack the carbon from backside. Okay, maybe we can repeat again. Okay, the nucleophile attack the carbon from the backside. Okay, and the transition state is formed. Okay, so this is the transition state where we can see there is a negative charge. Okay, because carbon has extra bond now. Okay, so what happened next? The X will leave the compound. Okay, X will leave the compound because X is a good leaving group. And inversion occurs at the carbon. Okay, and this is what I said just now. The structure is like umbrella caught by the wind. Okay. So the transition state involves partial bonding between the attacking nucleophile and the haloalkane. So we represent the partial bonding by drawing the dotted lines like this. Right. So relative reactivities of bimolecular nucleophilic substitution SN2. Okay, the reaction will be fast when the groups are small group, for example hydrogen only, and will slow considerably when larger groups are attached. Okay, the presence of bulky alkyl groups will prevent the nucleophilic attack. Okay, this is what I meant by the nucleophilic bulky alkyl groups. Okay, what does it mean by the small group? Like this, hydrogen has only one electron. The structure, the shape is quite small. Okay, but when we have alkyl groups, for example CH3, okay, it will help to prevent the backside attack. So if we have a methyl halide, okay, it is easier for SN2 to be to occur. But the reaction rate will decrease when we have greater number of alkyl groups. Okay, what happened here? The bulky alkyl groups, for example, the CH3, okay, this one, primary haloalkane, okay, compared to the secondary haloalkane where we have two alkyl groups attached, secondary haloalkane, compared with the tertiary haloalkane where we have three alkyl groups attached to the carbon. Okay, tertiary haloalkane. Okay, for SN2 to occur, it is quite difficult when we have the bulky alkyl groups because it can prevent the backside attack. Okay, so the SN2 reactivity of substrate on hydrolysis reaction. Hydrolysis reaction means we react the haloalkane with the nucleophile OH minus. Okay, so what happened here? Okay, the methyl halide is more reactive towards SN2 compared to primary halide, compared to secondary halide, compared to tertiary halide.